So for the next set of questions, we're looking to show that certain functions have properties of being concave up or down for certain values of x. To be able to talk about concavity, we need to remember that that's to do with the second derivative. So I'm going to need to find the first and then the second derivative. Fortunately, these ones are pretty quick, so I'll just jump in and do those. Using the power rule here, I get 2x minus 3. That's just the first derivative. I actually want the second. I can see that it's 2. What I have here, I need to show that it's concave up for all x. Well, it actually doesn't matter what x is, because this is always positive. So I can just finish this question by saying, therefore, as y double dash is always 2, it is always positive, therefore always concave up. Now, just to make sure we remember what this means, this is a positive quadratic, looks like this, concave up everywhere. That's what that quadratic looks like. So in this next one, we can see, let's just jump in and have a look at the question. It's minus 3x squared, so we should know instantly that it's a negative quadratic, upside down. That's concave down everywhere, so let's just show it mathematically now. The first derivative is minus 6x plus 2. Second derivative, minus 6. So because this is always minus 6, it's always negative, therefore always concave down. And that's just as we were expecting it to be. The next question is a hyperbola. So we know what this looks like. Let's have a little bit of a quick sketch. Got an asymptote at the axes. So the question is asking us to show that it's concave up for x less than 0, x greater than 0. You can see it's concave up here. And concave down for x less than 0. We can see it's concave down there. So I just want to show that mathematically. So we need the first and second derivative. So firstly, I'm going to rewrite the question as an index. Then I can find the first derivative. Just write that as a fraction straight up here. And then I can find the second derivative. Right, now let's have a little investigation. We need to consider the two cases, x less than 0, x greater than 0. I'm going to look here first. We're investigating the second derivative, which is 2 over x cubed. So now if x is less than 0, then my second derivative, this is 2, that's positive, divided by my negative number cubed. So remember that that means it's negative times negative times negative, going to be a negative number. So here I've got positive divided by negative, which is negative. Which means that this is always concave down. So the next one, we did the same thing. We're investigating the second derivative, 2 over x cubed. So we say, well, if x is positive, then this will be positive divided by some positive number cubed. Well, this is going to be positive, therefore always concave up. For this question, again we're looking for concave up and down. We can see it's a cubic. We know that this cubic is positive, so it's going to have extreme ends that do that. It could have some kicks in it that do something like that. We don't know where any of these particular positions are. So let's just have a investigation now and see what we can come up with. So I need the first derivative, but only because I need it as a tool to get to the second, which is 6x minus 6. So I just go, that's 6 lots of x minus 1. It might help me, it may not. We'll see what happens on the next step. I've got two cases to consider here. They want me to look at x less than 1 and x greater than 1. So let's just have a look at the first case. X is less than 1, then my second derivative is 6 times something that's smaller than 1 minus 1. That's going to be negative. That means this whole thing is negative, so therefore it's concave down. That's this part here. X greater than 1. So we say if x is greater than 1, then my derivative is 6 times, and if something that's larger than 1 I take 1 away, it's going to be a positive number. So that's positive, so therefore it's concave up. That shows that one.